Okay, we're going to review solving systems of linear equations using substitution. The exact solution for a system of equations can be found by using algebraic methods such as substitution. We've been doing substitution since the beginning of the year. It's just when you substitute a value in for the variable in an equation. So if we look at this system of equations, we know that y equals 3x. So we can use that to find the solution for the system of equations by substituting it into the other equation. We substitute the value of y, which is 3x, into the other equation. So I have x plus 2 times 3x equals negative 21. Then I just solve for x. So I have x plus 6x equals negative 21. Combine like terms, and I have 7x equals negative 21. I'm going to divide both sides by 7, and I end up with x equals negative 3. And that is going to be the x coordinate in my solution. So if you think about these two equations being graphed, the point where they intersect is the solution to the system of equations, and we now have the value of x at that point of intersection. Now I need to find out the value for y. Okay, and in order to do that, I'm just going to substitute in negative 3 into x in that first equation. So I have y equals 3 times negative 3, which leaves us with y equals negative 9. Okay, and I can check my work by substituting those values back into the equations. I have negative 9 for y. Okay, so it's negative 9 equals 3 times negative 3. That x and y value in that original equation have now been substituted in with the x and y value in my solution. And when I solve that, I end up with negative 9 equals negative 9. That's a true statement, so it works for that equation. Then I'm going to substitute it into the second equation, and I end up with negative 3 plus 2 times negative 9 equals negative 21. So I end up with negative 3 minus 18 equals negative 21, which is negative 21 equals negative 21. And this means that my work is correct and that negative 3, negative 9 is the point of intersection of the two equations. Okay? Now, here we have an example where we do not have a value for either of the variables. So what we're going to do is look at these two equations and find which equation can I use to isolate one of the variables. And I notice in the first equation I have x with no coefficient. So that's going to be the easiest one to do. And to get x by itself, I have to subtract 5y from both sides. And I end up with x equals negative 5y minus 3. So now I have a value for x that I can substitute into the other equation. So I'm going to do that with 3 times negative 5y minus 3 minus 2y equals 8. And what I did, I just substituted this in for x, and now I'm going to distribute the 3 to end up with negative 15y minus 9 minus 2y equals 8. I have to combine like terms. Okay, and then I'm going to add 9. And divide by -17. And I end up with y equals -1. And there's my y coordinate. And the next thing I need to do then is to figure out what x is. And I'm just going to go back to the first original equation and substitute in -1 for y. So I have x plus 5 times -1 equals -3. All right, then I have x minus 5 equals -3. I'm going to add 5. And I end up with x equals 2. So my solution for this system of equations is at the point 2, -1. And I would recommend that everyone check their work. I'm not going to do that now, but you substitute in 2 and -1 for x and y into both of the equations and solve, and if you get true statements for both equations, your solution is correct. The next example that I want to show you is a special example. Here I have two equations, and again I want to look at the two equations and find where I can isolate a variable. And I'm going to look at the second equation, and if I add 2x, I can get y by itself. Okay, so that equation is y equals 2x plus 4. Okay, and if I'm really careful, I can notice something about the two equations, but I'm going to ignore that for right now, and I'm going to go ahead and use substitution. So I'm going to substitute that into the first equation. So it's 2 times 2x plus 4 minus 4x equals 2, and now I'm going to solve for x. So I have 4x plus 8 minus 4x equals 2. All right, I have to combine like terms, and I have 4x and I have -4x. They cancel each other out, and I end up with 8 equals 2. This is an untrue statement. And what that means is that there are no solutions. Okay, and if we go back and look at the other two equations, we can see that they are parallel. Okay, I can simplify the first equation by dividing each term by 2, and I end up with y minus 2x equals 1. Okay, and that tells me that the slope of the two equations is the same. It's a slope of -2, but the y-intercept is different. And if we remember back to what we learned when we were looking at graphs of systems, if the slope is the same and the y-intercept is different, we have parallel lines. Since we have parallel lines, there can be no solution because the lines do not cross. Okay, so if you notice it at the beginning, that's great. If not, when you get an untrue statement, you know that there are no solutions.